Our discussion in this lecture is about phase shift, and obviously I haven't labeled this phase shift, but phase shift is a shifting of the trig functions to the left or to the right, a horizontal shift. And we've seen this earlier about how we deal with horizontal shifts when we were looking at transformations of functions in the algebra part. We know that if we add a number on the inside of the function, like if we have y is equal to the square root of x minus 5, that minus 5 causes us to shift left. Excuse me, to shift right. And if we have the square y is equal to the square root of x plus 2, that 2 causes us to shift to the left. So it's opposite of the direction we expect to shift. So when we go to graph this function, you'll notice that on the inside of cosine, we have 2x minus pi over 4. And that minus is going to cause us to shift to the left. Now, it's not going to cause us to shift to the, excuse me, I said this backwards again. The opposite direction is going to cause us to shift to the right. But it's not going to shift to the right by this amount because we have this 2x here. So let's first review the different pieces of this function. We're going to graph this, and we're going to go through step by step to make the graph. So let's remember generally that if we have a function of the type y equal a times the cosine over omega x minus phi, and I think I called those b, x, and a minus c previously, but that's all right. We know that the a causes an amplitude issue, and the amplitude of the function then is the absolute value of this factor, this constant factor in front of the cosine or sine function. And this omega causes a change in the period. And since we're talking about a cosine function, the normal period is 2 pi. We divide by omega to get our new period. Now, this phi, okay, that's a Greek letter here, phi, and this causes us a phase shift. And the phase shift is in the positive direction, and the amount of phase shift will be phi divided by omega. Now, phi is the number being subtracted from this x amount. So this subtraction sign is an issue here that we use just the phi. If we had a plus number here, then we would have to think of it as subtract a negative, and then the phi would be a negative number. So the whole issue is phi is what's being subtracted here. Anyway, let's go through the pieces that we know. So our very first thing is, in this function, we know the amplitude is the absolute value of 4, which of course is just 4. And then we calculate the period by taking 2 pi, as we say over here, and dividing by omega. Well, in this case, omega is this 2. So 2 pi divided by 2, which is pi. So the period of this function is going to be pi, meaning it makes one cycle, one complete cycle in pi units. Now the phase shift is the next thing. This is something we haven't done before, but as I mentioned previously, the phase shift is what's being subtracted from the x component here, and that's a pi over 4. So that's the phi, positive pi over 4, divided by omega, which is 2. So pi over 4 divided by 2 we can calculate as pi over 8. So the phase shift is pi over 8, which means we're going to shift the entire graph pi over 8 units to the right, a positive pi over 8 units to the right. And that makes sense. When we subtract, we expect a shift to the right. Okay, well, now we're going to approach this like we have in the past. That is, we're going to graph one cycle, and that cycle has to move between 0 and 2 pi normally. So we're going to get the cosine to go through all of the values between 0 and 2 pi, and so we need to make sure what x's cause 2x minus pi over 4 to take all the values between 0 and 2 pi. So that's the normal way we do this. We take the argument, set it between the normal beginning of the home interval for cosine function and the normal end of the home interval for cosine function. And then we just begin to solve for x. So the first thing we need to do to get x alone in here is to add a pi over 4 all the way through. And I've shown that in this step. Add pi over 4 here, add pi over 4 here, add pi over 4 here. Okay, and of course 2x minus pi over 4 plus pi over 4 ends up with 2x here. 0 plus pi over 4, of course, is just pi over 4. And 2 pi plus pi over 4, well, 2 pi is the same as 8 pi over 4 plus pi over 4 is 9 pi over 4. So now we have 2x in the middle, but we want to know the values of x. So we'll multiply through by 1/2. See, 1/2 times 2x will give us an x, but we have to multiply all the way through by 1/2. So when we multiply here by 1/2, 1/2 times pi over 4 is less than or equal to 1/2 times 2x, which of course is less than or equal to 1/2 times 9 pi over 4. Now, how does that simplify? Well, pi over 1/2 times pi over 4 is pi over 8. Of course, 1/2 times 2x is x, and 1/2 times 9 pi over 4 is 9 pi over 8. So the home interval for this function that we're actually trying to graph starts at pi over 8 and ends at 9 pi over 8. And just as a little reminder, let me kind of show you the idea is in this home interval, the distance between the beginning of the home interval and the end of the home interval has to be the period that we calculated. We calculated the period to be pi above, and if we take 9 pi over 8 and subtract pi over 8, we get 8 pi over 8, which is pi. So that is the period, and that's always going to be the case. The home interval goes through one cycle or one period. And to show you one other thing, the number where this home interval starts, that pi over 8 there, is the amount of the phase shift, because that's how much we're shifting that home interval, or the graph is being shifted. So as we go through this, you can kind of double check that you've done it correctly then. Okay, well, we're going to take this home interval then on the next page, and we're going to look at the 5 important points. So the 2 endpoints, pi over 8 and 9 pi over 8, and then we're going to split that in quarters. We're going to take half of that and then quarter each of them. So we see that on the next page, and I've done that. Okay, here's the beginning, here's the first x, here's the ending, there's the last x in the home interval. And when I split those in 2, I got 5 pi over 8. Now, I'll tell you how you can do that, is that the middle of these two is the average. So you could take pi over 8 plus 9 pi over 8 and get 10 pi over 8, and then divide that in 2, and you get 5 pi over 8. And then you might be able to figure, well, what's halfway between pi over 8 and 5 pi over 8? But if you can't figure it out, what's in between, halfway in between, is the average of these two. So if you take pi over 8 plus 5 pi over 8, you get 6 pi over 8. And if you half that, you get 3 pi over 8. And likewise, you can calculate here 7 pi over 8. If you can't figure halfway between 5 pi over 8 and 9 pi over 8, it's the average of these two. 5 pi over 8 plus 9 pi over 8 is 14 pi over 8, and if you take half of that, you're at 7 pi over 8. And that is a 7 pi there. It's a little hard to read. So those are the 5 important quarter points in our home interval that we're worried about graphing y values for. And so we just build up. Now remember, let's go back to the page here. Remember, this is what we're trying to graph. And so we're using the x's we just indicated, but what we've got to do is, before we can take the cosine, we've got to multiply those x's by 2 and subtract pi over 4. And so that's what we're doing on this next page. So first I multiply them all by 2. So pi over 8 times 2 is pi over 4. 3 pi over 8 times 2 is 3 pi over 4. 5 pi over 8 times 2 is 5 pi over 4. And so on. 7 pi over 8 times 2 is 7 pi over 4, and 9 pi over 8 times 2 is 9 pi over 4. Now remember, though, we're taking the cosine of 2x minus pi over 4. So I've taken this 2x value and subtracted pi over 4 each time. So if I take this 2x and subtract pi over 4, I'm at 0. If I take 3 pi over 4 and subtract pi over 4, that's 2 pi over 4 or pi over 2. If I take 5 pi over 4 and subtract pi over 4, that's 4 pi over 4 or pi. Likewise, 7 pi over 4 subtract pi over 4 is 6 pi over 4, and that simplifies to 3 pi over 2. 9 pi over 4 subtract pi over 4 is 8 pi over 4, and 8 pi over 4 is 2 pi. So it's these values we're actually taking the cosine of. And so we do that. The cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. And the cosine of 3 pi over 2 is 0. And back to the cosine of 2 pi is 1. Now, our y values are 4 times the cosine of 2x minus pi over 4. So our y values will be 4 times each of these above. 4 times 1 is 4, 4 times 0 is 0, 4 times -1 is -4, and you can see all the way across here. So we're going to plot the points pi over 8, comma 4, 3 pi over 8, comma 0, 5 pi over 8, comma -pi over 4. That's what we're plotting to make our graph, and that's going to give us our home interval. It's giving us 1 cycle. And so here's what I ended up doing. I ended up making each one of these marks pi over 8. So here's 1 pi over 8, here's 2 pi over 8, here's 3 pi over 8, 4, 5 pi over 8, 6, 7 pi over 8, 8, 9 pi over 8. And so when x is pi over 8, my y value is 4. When x is 3 pi over 8, my y value is 0. I mean, we know what the cosine function does. It starts high, and it goes to an x-intercept, and then it goes low, and then it goes to an x-intercept, and it goes high. That's what it does. And we're just illustrating that. Really, we have these values, and we know it's going to start here and go like this. But when x is 5 pi over 4, y is -4, so that's down here. When x is 7 pi over 8, y is 0, back to here. And when x is 9 pi over 8, y is 4, so back up here. So I've drawn that graph. That's 1 cycle, okay? 1 cycle, the home interval, if you will. Now, if I want to extend that, then I need to come out here and say, okay, well, here I need to mark off some more. Here's 10 pi over 8. Here's 11 pi over 8. And what happens next? It will go from this position to this position, okay? It's just like we're repeating what we see here. And then after it gets to here, it will go down. Well, anyway, I've done this. Let me send this one to the back, and I think that I've got it. There you go. So I extended. Here's 11 pi over 8, 13 pi over 8, 15 pi over 8, 17 pi over 8, and I knew that it would go from here to here to here to here to here, and so I dashed that in to the right. Likewise, every pi over 4 is what this is, 2 pi over 8. So if I go this direction, I'm going to have an important place. If I go this direction by 2 more of those units, which is pi over 4 or 2 pi over 8s, and to here and to here. So I just marked off, say I looked here. Oh, that's the distance. So go this direction, that's at -pi over 8. Go this direction, that's -3 pi over 8, -5 pi over 8, -7 pi over 8. I started out high, so I would know I would go to an intercept, and then I would go low, and then I'd go back to an intercept, and then I'd go back high. That's the way I did it. I didn't calculate these values separately. I knew what this was going to look like once I had this home interval. So it's really pretty easy if we work correctly. Okay, let's look at the next one then. We want to graph y equal 2 sine of pi times x over 2 plus pi over 2. Now, in this example, let's make it clear that because we're adding pi over 2, an addition causes a shift to the left, doesn't it? And here is the whole point of it, though, is that when we look at phase shift, we're assuming a subtraction sign here. We already know how to do the amplitude. We already know how to do the period. The phase shift is phi over omega, but that's assuming phi is the number being subtracted. So in this case, well, let's do this though. Let's get these two pieces out of the way. Okay, so we know the amplitude is the absolute value of this 2, which is 2. And the period, oh, let's be careful. The 2 pi divided by omega. Now, because of the way this is being written here, we might get confused about what omega is. So if you notice down here, I wrote pi times x over 2 as pi over 2 times x. That's the same thing, isn't it? And so my omega is actually pi over 2. So we take 2 pi and divide by omega, which is pi over 2. And in this case, and you can do the algebra separately, you'll get a value of 4. So the period is 4 here. Now, as I was saying, though, because of this plus sign, when we're trying to identify phi, we have to say what is being subtracted. And since we have a plus here, we have to imagine how we would create a subtraction. So to have a subtraction in that place, we need to subtract a negative number so that it ends up positive. And so our phi, the number being subtracted, is actually negative pi over 2. Okay. Well, once we know that, then we have the phase shift calculated as phi divided by omega. And phi, as we just illustrated, is negative pi over 2. And omega, as we talked about, is positive pi over 2. So we have a negative pi over 2 divided by a positive pi over 2, which is just simply a negative 1. So the phase shift is negative 1, which means the graph is going to be shifted to the left 1 unit, negative 1 unit. Okay, and that's what we would have guessed here, that it was going to shift to the left. Okay, well, we're going to go back to the idea now. How do we calculate the home interval of this particular sine function? Well, we take this argument and snuggle it in between 0 and 2 pi, because we need to take the sine of values that are always between 0 and 2 pi, and so we need to know what x's will cause this to be between 0 and 2 pi. And that's really our task here. So we begin to solve for x in the middle. So the first thing we do is subtract this pi over 2 in every interval area, in every position. Take 0, subtract pi over 2, take this argument and subtract pi over 2, and take 2 pi and subtract pi over 2. And as we do, of course, 0 subtract pi over 2 is negative pi over 2. And after we subtract pi over 2 in the middle, we have pi over 2 times x. And when we take 2 pi and subtract pi over 2, here's what we do. 2 pi is 4 pi over 2, subtract pi over 2 is 3 pi over 2. I'm saying that because it's hard for me to write at this point, but that will give you the idea of how you calculate it. Now, we need x in the middle, so rather than do a division, I think it would actually be easier to multiply by the reciprocal of pi over 2, which would be 2 over pi. So I'm multiplying by the reciprocal, 2 over pi, here, here, and here. And as I do that, of course, when I multiply 2 over pi with negative pi over 2, everything, what do I get? I get a negative 1. When I multiply here by 2 over pi, I get 1x. And when I multiply here by 2 over pi, notice that everything will cancel but that 3. So the home interval is between the numbers negative 1 and positive 3. Now this is similar to what I showed in the previous problem. Remember, the period is 4 and the phase shift is negative 1. This number will always be the phase shift number once we get our home interval. And the distance between, see, I did a little scratching and had to start over. The distance between here and here is the period. So if I take 3 and subtract a -1, I get a +4. So yes, between here and here is the period. And as already pointed out, this number on the left is the phase shift, and that's exactly what we had above. Now, we're going to take this home interval and break it into the 5 important points. We're going to break it into quarters, including the 2 endpoints, though, as a part of the important points. And so we do that on the next page. So here's the beginning of the home interval, x = -1. Here's the end of the home interval, x = 3. And I need to split that in half. And if I can't figure that out real quickly, then I can remember that it's the average of these 2 endpoints. If I take 3 and -1 and add them together, I get 2, and divide that by 2, I get a 1. And then halfway between -1 and 1 is 0, and halfway between 1 and 3 is 2. So, and of course there's 1 unit in between each of these. That's how I know I've done it correctly. So those are the 5 important x values. Now, once again, let's remember what we're trying to do. We're trying to calculate y. So we have the x values, but we need to calculate pi/x divided by 2 plus pi/2. So the first thing I'm going to do is worry about calculating pi/x times 2, or pi/2 times x, which is equivalent. So that's what we're doing over here. So I took these x's and multiplied each by pi/2, and that's what we get. pi/2 times -1 is negative pi/2, and of course pi/2 times 0 is 0, pi/2 times 1 is pi/2. Pi/2 times 2, though, is pi, and pi/2 times 3, our x is 3, is 3 pi/2. Now remember, we need to calculate pi/2x plus pi/2 because this is what we're taking the cosine of. So I took each of these values in this row and added this pi/2. So when I take this and add pi/2, I get 0. When I take 0 and add pi/2, I get pi/2. When I take pi/2 and add pi/2, I get pi. When I take pi and add pi/2, I get 3 pi/2. And when I take 3 pi/2 and add pi/2, I get 4 pi/2, which is 2 pi. So these are the values we're actually taking the cosine of. These x's give us these arguments for taking the cosine. Excuse me, the sine. Well, we're doing sine, aren't we? So we take the sine of each of these values. The sine of 0 is 0. Sine of pi/2 is 1. Sine of pi is 0. And the sine of 3 pi/2 is -1, and finally the sine of 2 pi is 0. Now remember though, our y values are actually 2 times this sine value. So I'm calculating the y values that go with these x's. So 2 times the sine value, 2 times 0 is 0, 2 times 1 is 2, 2 times 0 is 0, 2 times -1 is -2, and 2 times 0 is 0. So now I have my 5 important points. Okay, my 5 important points. And so I'm plotting those 5 important points for my home interval. So when x is -1, y is 0. And see, the sine function starts at on the x-axis, doesn't it? And so that's really what we've got, is we're shifting, if you notice, and I didn't mention that earlier, but we're shifting the regular sine function 1 unit to the left. That's what we actually have got going on here. And then when I have an x value of 0, my y value is +2. And that's what happens. The sine function starts at the x-axis, and then it goes up to a high point, and then it goes to a low point, and then it goes, intercept. And it goes to a low point, and then back to an intercept. And by the way, I put my x values -1, -1, 0, +1, +2, +3, corresponding to these values. So when x is 1, y is 0. That's this point. When x is 2, y is -2 at this point, and when x is 3, y is 0. But that shouldn't be a surprise about the way this graph looks right there. Okay, we've taken the regular sine function and we've shifted that home interval over one unit to the left, 1 unit to the left. Okay. Now, I'm going to extend this, and so I'm going to mark off 4, 5, 6, 7, 8. And then I'm going to figure out, well, what's going to happen next is going to go to a high point, and then it's going to go to an intercept, and then it's going to go to a low point, and then it's going to go to an intercept, and then it's going to go to a high point. It's just mimicking this, isn't it? Let's see what that looks like. And there I've got it. So I marked off 4, 5, 6, and 7. These were 1 unit apart. So it goes to a high point, then it goes back to an intercept. It goes to a low point, goes back to an intercept. So this dashed part is just a continuation of this one cycle, okay, that we see here. And then I went to the left and did the same thing. And so what we see here is the same cycle that we see here, except of course it's further to the left. And we know that this continues to the right forever and to the left forever. Now, as I was doing this, it dawned on me, back to the original problem, the cosine function. Let's back up all the way. Okay. Remember, we said that the phase shift was pi over 8. And so it was going to be shifted pi over 8 units to the right. And on the next page, you see the regular cosine function would normally start here, start high, and then go down. But we've shifted that whole portion of that home interval pi over 8 units to the right. And so instead of starting here, it's starting pi over 8 units to the right. And I don't know if I made that clear. That's the phase shift part of it. It's been shifted to the right. Well, I hope this is useful, and you can use this to work on your homework. The same kind of thing works for tangent function, cotangent function, secant function, and cosecant function. And it's just the same pattern that we use on each of those as we've done here. So like I said, I hope this helps. Good luck on your homework, and let me know if you have some trouble or questions.